In this one, we're going to prove to ourselves that the following is true. -1 plus the square root of 3i over 2, that whole quantity cubed is equal to 1. So the first stage is, you see over here above my head, there's a 3 in the exponent. When you have that case, you can distribute that 3 over to the numerator and the denominator individually. So distribute the 3. So it becomes -1 plus the square root of 3i quantity cubed, and then also in the bottom I have 2 cubed for that reason. Now 2 cubed is 8. That means you can basically factor out 1/8 to get 1/8 multiplying the rest of it. That -1 plus, let's see, the square root of 3i, the whole quantity cubed. Just pull that 1/8 out of the fraction. Now, because you see over here, I have a 3 as the exponent, I need to apply this rule that says that a plus b cubed is equivalent to a cubed plus 3a squared b plus 3ab squared plus b cubed. So I'm going to apply this rule as follows. In our case, a can be identified with -1 and b can be identified as the square root of 3i, basically. That's all. So where am I getting that? Take a look. Over here, you see above my head, that's -1, that's a. And the other part, the square root of 3i is like b, basically. So that means every a is replaced with -1, and then b is replaced with the square root of 3i. That's all. Let's continue. So make the actual replacements. So it becomes, in other words, -1 plus the square root of 3i cubed becomes -1 cubed, and at this step be very careful, plus 3 times -1 squared times the square root of 3i, so just replacing for a and b in this expression above my head back at step number 4, keep that in mind, that's all I'm doing. Then it's going to be here plus 3 times -1, the value of a, times the square root of 3i, that's the value of b, and then you square that. And lastly, at the end, you do the square root of 3 and then I, the quantity cubed. So plug into that basic pattern for expanding a plus b cubed. Let's work this out though carefully. So now, this -1 cubed, that comes down as -1. Here it's going to be 3 times -1 squared. Well, -1 squared is 1. 1 times 3 is 3. And then you're going to keep it multiplied still by the square root of 3 with the I. So it comes down here as 3 times the square root of 3i for that reason. Next, I have 3 times -1, and then over here it's going to be also the square root of 3i, that quantity squared. So that's going to come down here as follows. The 3 times the -1 comes down here as -3 above my head. Very carefully, look. Okay, and now remember that here, back at step 6, if you take the square root of 3 and you square it, the square root goes away. So for that reason, right in the middle above my head, step 7, you end up with just a 3. Lastly, when you apply the exponent of 2 to the I, that comes down just as I squared for now. Let's look at the last term. So you have, that's the b cubed term, in other words. So it becomes the square root of 3i. So you're going to apply the 3 in the exponent to the square root of 3 and to the I individually. That's going to give you here square root of 3 cubed times I cubed. Let's work this out. Here's just a lot of perhaps somewhat tedious algebra, to be honest. So it's -1 plus 3 times the square root of 3i by the 3 times 3 I squared. And notice that this is still the square root of 3 cubed times I squared times I. So there's a difference here. Look carefully. Right here above my head, I have it as I cubed after you distribute the 3. But then here I've written it as I squared times I, because I want to identify anything that's an I squared, because I know that value is equal to -1. So then I can pick up at step 8. So replace every occurrence of I squared with -1. So here this is already worked out. -1 plus 3 times the square root of 3i minus 3 times 3 times -1. So that will be, this was back here an I squared. Remember, that came from this I squared right above my head, you see? Back at step 7. So that's why it has to be -1. Continue. The square root of 3 stays cubed, and then back here, you see that I squared back at step 7. Also now at step 8 has to be replaced with -1. And the other I is kept exactly in that form. Again, this is just a lot of algebra. Let's continue. So multiply out. I will have -1, 3 times the square root of 3i, and then plus 9. Where's that 9 coming from? Think about it. Back here at step 8, I have -3 times 3 times -1. Well, that's -3 times -3, which is +9. So that's why here I have +9 above my head in that position. Okay, also notice that back here I have the square root of 3 cubed times negative 1 times I. That negative 1 will go in front of the whole cubed square root. So come down here as negative, let's see, cube of the square root of 3i. Lastly, let's finish this up. I can combine the negative 1 and the 9. When I do that, down below at step 10, it's going to give me that nice 8. Also, the 3 times the square root of 3i can be rewritten as plus 3 raised to the 3 halves. The reason is that, remember, this is 3 to the first, and when you say the square root is 3 to the 1 half, correct? So 1 plus 1 half will give you a 3 halves as the new exponent, and you copy the I. For the other part, I have minus. This is 3 like that. So this is already a 3 up here, and then you have, a 3 that exponent. And remember that the implied index of these expressions is 2, correct? So the exponential version of this factor above my head can be written as minus 3 to the 3 halves times the I. And I notice that this term above my head at step 10 and that other term are opposites because they have different signs, so they will cancel off. That's going to give you just the 8 from here. Lastly, go back all the way to step 3 across the top. Remember that here we factor this 1/8 out. We can't forget about that. So down below, multiply the 8 from step 10, so this 8 from step 10 right here. Multiply that by that 1/8 from step 3 across the top. So 8 multiplied by 1/8 right here will give you 1. And this basically confirms what we set out to confirm, which is that the value is 1. So in other words, this expression back at step 1 is equal to 1. I've shown you this example using, for example, only the positive side between the negative 1 and the square root of 3i, but something very similar applies, for example, if you had a negative side. But that's it for this one. Thank you so much for watching. Please leave a like and subscribe. I will see you in another video.